Let's get started in 4 minutes. I hope no one's at the in the classroom today. Is anyone here actually in the classroom right now? Didn't see my Piazza post. Let's wait for a couple more minutes. Let's wait for a few more minutes for more people to tune in. All right, someone just joined and their name is Monk. I don't know who Monk is. Oh, there it is. There you are.
It auto completed. I'm sorry. I can change it.
That's real funny. I appreciate it.
That's the name of my like local device. So I guess it reads from that. Anyways.
I'll have my camera on in a second, but basically, yeah, I don't know if I got COVID or something, but it's really bad sore throat right now, and starting to cough a bit. So even I get COVID. So not everyone's safe. But well, this morning, inflation numbers came in. If you're following the price action of all the assets, they all took a huge dump. Bitcoin's down by 10% or something right now, which is business as usual. Okay, here I am. Looking a bit rough today. My voice is a bit weird, deep, because I can't really talk too loudly because my my throat's not cooperating. That's fine. Okay, let's get started here. So last time, what did we talk about last time? Last time we we kind of started to get into the programming stuff, right? We talked about what programming really is, what are variables, how they're roughly formatted, right? Some common some common types, so different types of variables. We also revisited pre-algebra, right? How to add numbers, but of course, the point of doing that is to ease you guys into adding numbers, doing calculations using binary. How that works. All right, difference between signed and unsigned integer. And yeah, this is kind of where we left off last time, right? So we can keep going now. Okay. Actually, before I start, any questions regarding these things, the stuff that we talked about last time? If I don't hear anything, I'll assume that no one has any questions. All right. Okay. So let's move on to this thing called, I'm sorry. Let's move on to this thing called mapping. Okay. Now, what is mapping? Mapping is the first and more or less only complicated data structure that you'll see that we'll get to work with in Solidity. The other one is just an array, and an array is very easy. We'll get to it in a bit. Okay, so mapping is probably the most complicated data structure that you'll come across in Solidity. It is the most complicated data structure that Solidity will allow. And this is also part of the reason why, and this is probably by design. You can't build anything that's really complicated with Solidity. Because on-chain computation it's expensive, so they want to limit what you do. They want you to, when you approach a problem, they want you to boil the problem down to its very essence. Oh. Sorry, my cats are doing weird things. Anyhow, So mapping, again, Solidity doesn't allow us to do anything that's really complicated, which is probably a good thing, because if you think about it, every single computation and whatnot, they require gas, right? And if your program's too complicated, then it becomes too difficult, too expensive for the users to use. And also it just becomes too heavy for all the nodes to replicate. Okay, so how do you explain mapping? So for those of you who's taken computer science courses before, who has knowledge in computer science stuff, mapping and Solidity is comparable to a hash map. Okay, I won't ask you to explain it, but so a mapping, for those of you who haven't programmed before, you can think of mapping as a one-to-one relationship. Okay, you're basically associating one element with another element. Okay, so for example, on like the grades and roster portal for us faculty members at USC. Okay, every single person, or actually it's not even that. Okay, so yeah, in this case actually, so every single one of you, you have your own student ID at USC, right? It's I don't know, 10 digit or something, 11 digits, 12. The point is, every one of you, you've got a student ID. Okay, and because each one of you has a unique student ID, we can say that each student ID is uniquely associated with one name, more or less. Okay, not taking into account, of course, people having the same names. That happens once in a while. Right, but generally speaking, for the majority of the cases, each student ID corresponds to a single name. Okay, so it's a one-to-one relationship, if you think about it, because one student ID corresponds to one name. Okay, so that's basically how you can understand mapping. Okay, so in this case, and by the way, the syntax for mapping on the left side with the blue box, you can see. So intuitively, I think it's a pretty intuitive way of showing how mapping works, or the type of a mapping. So a mapping is a type on its own, but within a mapping, there are also different types of mappings, right? Because you're mapping from one element to another, right? So the first element has a type, the second element also has a type. Okay, so in this case, we're trying to map a ITP-356 to a string. Okay, so this is the case that we talked about with the student IDs, right? So let's say my ID is 0, right? In this case, well, see my name, Jack, it's associated with the ID 0, okay? And ID 1 then points to James. So James has a student ID of 1, all right? And 2 points to J, okay? I don't know why I have names starting with J. Anyhow, and there are a couple of rules or properties of mappings in Solidity. The first one being that it doesn't have to be continuous. Okay, the numbers, like, they don't have to be 0, 1, 2, 3, 4. You can see here, I did 0, 1, 2, and then I skipped right to 5,534, and that's totally fine. Okay. You see, it doesn't have to be in order. Okay, you can skip keys all you want. And by the way, so you see how 0 is associated with Jack. Okay, so in this case, 0 is called a key and Jack is called a value. The reason it's called that is because when we're trying to look up this mapping, we're trying to make use of it, we always use a key to look up a value. Okay, so in this case, the purpose of this mapping is given any student ID, this mapping can return the student name if available. Okay, now, and which is why it points from a number to a string, right? But it can't go backwards. Now, if you want a mapping that points from a string to a number, then you'll have to reverse it. You'll have to do mapping string pointed to ITP-356, and then that way the key will be student name. So in that case, we'll basically flip the order between the name and the number. My cat is making. Give me 1 second. I can't handle this. They're being too loud. I'm sorry. All right, I'm back. Okay. So we were talking about if we wanted to say go from a student name to a student ID, then we have to flip the mapping, right? So the mapping would have been a mapping that maps from string to an uint, right? And the way that we can get a value with a key in a mapping is by doing this. I can't point to things. Sorry. Okay, it's by doing this. Okay. Basically, let's say we have a mapping, and a mapping, and again, we're basically declaring a variable here. Okay. So this mapping, we're storing it in a variable named A, uppercase A. Okay. And this mapping is the mapping, yeah. It's a dynamically allocated array. Not so much, and you'll see in a bit. Okay. One of the reasons being because for an array, you can't skip indices. But for a mapping you see here, it doesn't have to be continuous. Okay. And also there's another property of mapping that we'll talk about later. Okay, that's different from an array. Anyhow, so coming back to getting a value from a mapping. So let's say there's this mapping, we stored it in a variable named A, okay, and the type, it points from a number, an arrow. So it points from a number to a string, basically what we have on the left here. Okay. And given a key, okay, this is some value that we already know that we're trying to plug into the equation, basically. Okay, so how the way to get, so given a key, which is the gray numbers on the left side, the way to get the string on the right side is by doing this string val. That's just the number, sorry, the name of the variable that I choose to store the value in. You can name it string name, string ABC, whatever, right? The variable name doesn't matter. Okay, but it should be intuitive, okay, because you'll have to understand it later on. But again, right here, it doesn't matter. So string value, okay, equals A, which is the name of the mapping, and then square bracket key. This is how we basically get a value out of a mapping, okay, using square brackets. Now they're called subscript operators. Again, if you come from a computer science background, then you'll know what this is exactly. In arrays or Python dictionaries or whatever, hash maps, this is more or less how you get your values. But think of it as basically, so here's an analogy, okay? Think of the mapping as a book, okay? And these numbers in front. So this again only applies to this specific mapping I'm talking about because the analogy has to do with numbers and whatnot, okay? So let's say this mapping that maps from a number to a string. Let's say it's let's say it's kind of like a book, okay? And if you want to find a certain paragraph or a certain whatever in the book, the way you look for it is by looking at the page numbers, right? So you can basically think of the key as a page number here, okay, and the value as whatever's on that page. So here what I'm saying is basically I am trying to get the value on I'm trying to get the value on within this book or mapping A on this certain page. That is key. Okay. So key in this case is a number because our mapping again is mapping from a number to a string. Okay. Now, this is about getting the value. We can also set the value. Okay. So we can also flip to a certain page and rewrite its contents. Okay. The way to do it is basically the reverse. Okay. So A square bracket the page number that you want to write the things onto equals whatever you want to write on it. Okay. Now this could be like Jennifer or something, right? And then let's say key is 0. Well, if we do this, okay, then Jack will become Jennifer. Okay. So this is how it works. Okay. Mapping is the single most confusing thing in Solidity. Okay. It might sound like I didn't take too much time to explain it, but the logical association between two elements, this one-to-one relationship. If you've never touched computer science or any kind of mathematics before, it could be, you have to take some time to understand it. Okay. And so we're actually going to spend quite a bit of time trying to understand mappings. So please, right now, immediately, do you have any questions? Do you want me to repeat any parts? Because mapping is incredibly important, okay, in Solidity, and it's also one of the things that's the most difficult to get. Okay, so make sure you really know this. Okay.
Jack, so what would be like a primary function, or like why would you want to use mapping?
Yeah, so let's say you have this smart contract. Oh yeah, so the most basic example, let's say you are, in the case of any ERC20 token, let's say USDC. Okay. We all know what USDC is, right? We talked about it a bit. It's a stable coin, one-to-one relationship with the US dollar. Okay, issued by Circle, backed by Coinbase and whatever. Okay. And in every single ERC20 smart contract, including USDC, the way they track balances is by using a mapping that maps from an address to a number. Okay. So given any address, it will return you a number, and that number will be your balance.
Okay.
Does
That makes
that-
sense.
Yeah.
Yeah.
All right. Any other questions or more examples I can give? Anything to help you guys understand it better? Because historically, and by historically I mean from one semester of teaching, people seem to be confused on mapping a lot.
I have a question, which is,
Yeah.
are the data types always like, are the key value data types always the same? I.e., you can't have like, a mapping that maps to values that are different data types.
Yeah. So all the keys and all the values have to be the same data type. Like it has to be internally consistent. Okay. So once you decide on what data type to use for a key, all right, then all the keys have to be that type. And once you decide on a type to use for a value, all the values have to be that type. Does that answer your question?
Yeah, perfect. Thanks.
Okay. So this is if you guys have programmed in Python before, and this is one of the reasons I hate Python, because there's too much magic going on. Python allows you to mix data types in things like arrays and whatnot. I think that's just horrific. You can tell I'm a Python hater. But yeah, in any real language, you can't do that. Okay. right, any other questions here? The next slide will be some inception shit, okay? So make sure you at least half understand what's going on here, because what's coming up, it will be a bit more confusing, okay? It will be one more layer of abstraction, meaning that your brain has to work twice as hard to understand it, okay? Going once, going twice. Okay, so I'll move on to the next one. I can come back to this one anytime. If you have questions anytime, just speak up. Or if you're shy, type in the chat, do whatever, okay? Just make sure you ask those questions, okay? All right. Okay. So now we have, I heard you like mapping, so I've got a mapping in your mapping, okay? Nested mappings, we can do that, okay? So a nested mapping, it's basically what it sounds like. It's a mapping, it's a mapping within a mapping, okay? And then you can nest however many layers you want, as long as you don't blow the gas limit, okay? You don't run out of gas, you can do however many layers you want. Right here, we're just doing 2 layers, okay? So, this is not a very practical example. I should change it. But right here, we have two mappings, okay? One mapping nested into another mapping, okay? So the first layer is a mapping that points from a number to something, okay? And that something is another mapping that points from a string to a Boolean. Remember, a Boolean is just true or false, okay? So we've got a number pointing to a mapping that points from a string to a true false, okay? Getting complicated here, all right? You can see here, okay, actually, okay. You can see here, so this is a visualization of how this works, okay? On the first layer, we have a mapping that maps a number to something, okay? Now we've got 2 numbers here, 200 and 4567, okay? And then you see behind these numbers, I don't know what my cats are doing, but they're making a lot of noise. Okay, anyhow. So we can see behind the number here, okay? So under the first nested layer of mapping, let's just look at what's on the right side of 200, okay? You can see this is another mapping of sorts. This part isolated with the delta, omicron, and sigma, okay? This part isolated looks exactly like this, kind of, okay? It's just pointing from a key to a value, okay? String to Boolean, delta true, omicron false, sigma true, okay? Speaking of which, I'm wondering if there eventually will be like a COVID sigma variant. That'll be funny. Anyhow, so there's that, okay? And you see, and let's take a look at what's on the right side of 4, 5, 6, 7 here, okay? Now we have another nested mapping, okay? And basically, again, string map to a Boolean, okay? So the way to access a value, so the value will always be the one that's on the right side, okay? The way to access it is by doing, you see how over here we only have 1 square bracket, 1 pair of square brackets, right? So that's just 1 level. Now we have 2 levels, so we have 2 square brackets, okay? So A, which is the name of the mapping, 200, okay, now that points us to 200, not 4, 5, 6, 7. That narrows down the results to here, okay? But within here, this is another mapping, so you have to give more information. And okay, I want to take a look at what's under sigma, okay? So let's look at sigma, and that will give you a true, okay? So that's how this works. Now, a few properties regarding mapping, okay? We talked about it, so we talked about how you're able to skip keys. Okay, you can skip indices basically. So you see how 0, 1, 2, and then it doesn't have to be 3. Okay, I can just jump to 5,000, 35,000, or 350,000. I can jump wherever as long as it's within the UNT256 range. Okay, it doesn't have to be continuous. Okay, and the other property is that you may have seen, okay, like I've defined, let's say I've defined 7 keys. Okay, I've given 7 keys values here. Okay, what about the keys that I never gave value to? Okay, what about so what is the value of key 3, right? So in Solidity, if you haven't set something in the mapping, so if you, let's say I haven't set a value for key 3, okay, because I just didn't do it here. If you can look at it, right? I jumped from 2 to 5,000. Okay, in that case, the value, the value that key 3 points to will be the default value for the type. Okay, so the value type is string. The default value is just an empty string. Okay. Now, if the value is a number, then the default value will be 0. If the value type is a Boolean, then by default it will be false. Because if you guys remember, I said Booleans are basically uint8s, they're numbers. Okay, so 0 represents false, 1 represents 1. So default value for numbers are 0, and that translated to Boolean will be a false. Okay. Yeah, so if we take a look here, okay, let's say we for the first layer that we go down here, okay, let's actually go back. Okay, so if I change key to 3, what do you guys think the variable val, what the value is for this variable?
Blank string.
Yeah, it'll be an empty string because we never set it to anything. It will just default to being nothing. Okay, so what about 4?
Same thing. Yeah.
Sorry.
Wouldn't it just be the same thing?
Yeah, it will also be empty. So as long as you didn't, as long as we have not said anything here, okay, if we haven't set it, then it will be the default value, which is the default value for the type. So in this case, it will be an empty string. Okay. And this is how it's different from dynamically allocated arrays, as Jacob, he was asking earlier. So dynamically allocated arrays, you can't skip indices. Okay, and for an array has a size. Okay, but the mapping actually doesn't. The reason being, if you think about it, okay, if all values that haven't been initialized defaults to the default value, then basically, like if we do A4 here, we're still able to get back a value. It's just an empty string. Well, then how do we know if this value hasn't been set before, or did we just set it to like an empty string to begin with? Okay, so basically in an array, you allocate a certain length first, and then if you go past that length, the program throws an error because you've gone past the maximum length. But in a mapping, all right, because everything is initialized to the default value, and it only, so if I didn't do 0 equals Jack here, then 0 will just be by default an empty string. So in Solidity, every single value to every single key is already initialized to the default value of the type. Okay, so technically, all the keys exist, all the values exist, they're just empty. Okay, so this is why you can't tell the size of a mapping, because the size technically, okay, if it's a UNT256, if the key is a UNT256, then the size will be 2 to the 256 minus 1. Okay, because you have that many possibilities for numbers. Okay, so technically every single key, every single value in a mapping exists. It's just a matter of if they're empty or not. Okay. So this is why in some instances you can't really use mapping, because let's say or you need like a separate counter to keep track of the size, because let's say you are trying to calculate the ERC20 example said earlier with the mapping from address to uint, right? So that's keeping track of the balance for each address. Okay. And in that case, let's say if you want to keep track of how many people hold tokens, all right, you kind of need, if you want to do it on the blockchain, like within the smart contract, you kind of need another variable uint you need to basically another piece of logic to keep track of how many people has their balance changed from 0 to something, because technically in a mapping, like all the users, all the addresses that there ever will be exist. It's just a matter of if they have a balance or not. Okay, so there's no concept of length in the case of mapping, because the length will just be the entire number range, like all the possible values. Okay. Now, take a minute to come up with some questions. I'll go get some water. Okay.
Jack, I have a question. Is there a way to like figure out, like you said there's no length of it, but is there a way to like get the amount of like keys you have, like a dot key or like no other like a
Yeah, so the problem again is all the keys technically exist. It's
Mhm.
just that the value that they're pointing to, if you've never said anything, they'll be empty.
in other languages that's possible though, right? Just not in Solidity.
Other languages, yes, they keep track. Yeah, the way Solidity works is different. The main reason being in Solidity, I think it has something to do with the fact that memory spaces and storage spaces need to be allocated before runtime. So when the contract's being deployed, they have to already have different virtual space allocated to different parts, different variables and whatnot in storage. So you can't have a dynamic, and you'll see in the future, you basically, there's some limitations as to like, basically you cannot have a dynamically allocated storage array. You can only have it at runtime. So everything that's storage, the size and the length and whatnot, they have to be already fixed, which is why it's kind of initializing everything at the beginning. So it's kind of just leaving out storage space for everything, at least in virtual memory address, so that in the future storage, the storage layout doesn't change. The storage contents can still change, but the layout shouldn't change.
Okay, thank you.
Yeah. Now, if you didn't understand what I said, don't worry about it. Okay. This is more for, deeper under, like if you coming from other languages, like basically all other languages, you're able to iterate through all the available keys, or sometimes all the available values, all right? You can even flip a mapping in other languages. Some languages call it a dictionary or something. But in Solidity, you can't do that, okay? But I was just comparing it with other languages. Don't worry about it. Okay, do we have any, let's see, am I missing anything about mappings? I think that's pretty much it. So Yeah, just a few kind of. Yeah, like just like most things in Solidity, the rules are simple, but it's mostly, for you to, the hard part is usually for people to grasp the idea of a mapping or a dictionary for the first time if you haven't programmed before. Okay. All right, do we have any questions so far about mapping? We can come back to it. You can like, if right now you're kind of still trying to digest and you come up with a question later on when we're asked some other slide, just feel free to ask and we can come back to mapping anytime. Okay. Okay, so another example. Let's say okay, so what if I do this? Okay, instead of 200, what if I do 400? What will val be?
Be false, right?
Nothing.
Yep, it's gonna be nothing because when we look at 400, there's no 400. I didn't set anything to 400. Okay, so 400 will basically point to an entirely empty mapping. Okay, and within the empty mapping, and again, all the keys exist. It's just that the values are default values. Okay, so the key sigma does exist, but because the mapping wasn't even there to begin with, so we're trying to find the key. We're trying to look for the value that corresponds to a key in an empty mapping. So the value will just be empty and it will be the default value, which is false. Yeah, Emily, what's up?
So if it was 200 instead of 400, would it be Omicron? Or
Well, okay.
it would be true, right?
It will be true. Okay. Omicron is a key. Okay. So the value, so it doesn't matter how many layers you have nested. There's only one value, kind of. Okay. Basically, you can't go halfway. Like I can't do this. That will just point me to another mapping. And then like I have to, like, you can't just return a mapping. Okay, because technically a mapping is infinitely big. Like you need to return a concrete value. So within the mapping, you must again specify which key you're looking at. Okay. Yeah. So you can think of the number of pairs of square brackets. It directly corresponds to how deep the nested mapping goes. You can see here with just one layer. Okay. No nesting. We have one pair of square brackets. Here it's nested 2 layers. We got 2 pairs of square brackets. Okay. Oliver, you had a question?
Yeah, no, I think I understand it fully now, but I know we both gave answers at the same time to the previous question. So just to clarify, that answer was false because
For 400, right?
yeah, for 400, the answer, even though it's pointing to like a mapping that doesn't exist because the end value is Boolean, it would be false.
Yeah, so it doesn't exist.
So wouldn't it
okay,
be like
so-
NaN or something? Not
No,
a
no,
number?
So the wording, I should have reworded it. It's not that it didn't exist. It's just that we never modified it. We never changed it from the default state because remember, in the mapping, all the keys and all the values, they technically exist. They're just empty. Okay, so technically, you have 2 to the 256 minus 1 possible keys here. All right, and each key corresponds to a mapping. So we actually have 2 to the 256 minus 1 number of string to bool mappings within this outer mapping. Okay, it's just the question isn't if they exist. It's just that if we've modified it so that the value is going to be different from the default value. So you kind of have to get used to the idea of everything existing. They're just the default value instead of like a null pointer or null or something.
Got it.
Yeah, makes sense. So the default value in the case of bools would be false.
Yeah.
Okay, and then it'd be like 0 in the case of integers.
Yes.
Okay.
So like, yeah, because if you think of Boolean, again, underneath is a number, and what's the default value for number? It's 0, right?
Hmm.
So 0 represents a false in Boolean.
And then like string
So-
would be like NP string, stuff like that.
Yeah.
Okay.
Can you only nest like mappings that are identical in terms of the data types they map to? So like you couldn't nest like a string to bool and a string to integer mapping within another mapping?
How would that work?
Yeah, I don't know. I have no idea.
Yeah, but what you're describing are two complete mappings, right? In order to nest, you can only have one complete mapping, and the other one, and that complete mapping will be the value for the other mapping. So the other mappings will always be just halfway, and the other half is whatever the complete mapping offers.
Okay, actually now I know what my question is. So is
Yeah.
the like string to bool in this case the data type for the mapping, i.e. like
The
if
data
you-
type for the inner mapping.
for the yeah, exactly, for the inner mapping.
Yeah.
Like if you did string to integer and then put in like the same thing down here, well, I guess you'd have to put like int 256 value, and you replaced like would that point, would a 200 sigma point to a completely different mapping? Does that make sense?
I mean, are you saying
Hard
you
to
could
articulate.
are you saying like within the same outer mapping you can have inner mappings of different types?
Yeah, like if you had an inner mapping that was different, that was, instead of being string to bool, it was string to int, could that mapping like exist for the same key?
Are you saying
Entirely
can you,
separate different mapping?
are you saying can you mix types?
Not exact. So okay, so if you were to change the code here to like uint 256 val a 200 sigma, like the exact same thing except for you change, would that point to a complete, like could you have a completely different mapping stored for that?
And then it wouldn't be a anymore. It would be a different variable, right?
Oh yeah, okay, yeah.
Because once you declare this a of the with this typing, you can't
Yeah.
change it anymore. Okay, if you want the uint, if you want the inner thing to point to a mapping for a different type, you need to use a different variable to house it.
Okay. Yeah, makes sense. So the a only refers to like a specific outer inner mapping
Yeah,
structure.
and so that's called the type. And the type, once defined, when you first declare the variable, which was kind of what we did here. Okay, this is called declaring a variable. Now you see when we declare a variable, here's the type. Okay, and this is also declaring a variable. It's just the value we're getting it for somewhere else, for some other variable. But once you declare the type, you can't change it. So if you want to work with a different type, you have to make another variable.
Got it. Thanks.
Okay, any other questions? Okay. All right, no more questions. Let's give me 1 second. Okay. So let's move on to functions. Okay. What are functions? Okay. Function is well, everyone can read, but I'll read it anyways because I wrote it. A function is a reusable collection of related but smaller actions. Okay, so think of a function as it's like how you put similar files into the same folder to group them. It's a way to group a group of actions that will be frequently repeated or something, will be reused. Okay, so that in the future, when you want to redo the sequence of action again, you don't have to copy and paste all the individual actions. You just have to call this function and it will basically rerun that sequence for you. Okay. It's like a sequence of actions. There we go. It's a better way of explaining that. Okay. So for example, starting your car is a function. Okay. So you can break down starting your car into the following steps. Okay. You have to walk to the car. Okay. You have to pull the door handle, open the door. You have to sit into the driver's seat. You have to close the door. You have to put your foot on the brake pedal unless you drive a manual, of course, if you're fancy, or if you don't have start stop. And then you push start stop button, let go, and then your car started. Okay. But every single day, or rather on Tuesdays and Thursdays, when I normally get ready to drive to downtown LA to give this lecture, I don't think, like, I just think that, oh, it's time for me to go to my car and drive there. You see how I'm abstracting away all the minute steps. Like I'm not saying like, oh, like I'm not gonna think like, oh, it's time for me to walk out the door, lock the door, walk downstairs, into the garage, into the car, start the car, get onto the freeway, get into carpool. Like I don't think about that, right? I just think, oh, okay, it's time for me to go. Okay, so you can think of that as like a huge function that basically encompasses a bunch of smaller actions. Okay. It's something that humans we've developed intuitively, but you don't think about it until we start to try to replicate these things in computers, and then we really start to think about, oh, okay, so this is how we're doing things. This is like we're kind of breaking down our thought process, the things that we just kind of glance over every day, like how to do it actually step by step. Okay. Okay, any questions so far about like what functions are? Okay, no questions. Starting your car. Okay. So functions, they're basically a way to group a bunch of code, bundle it into a single entity, okay, and abstract it. Okay. So functions the code inside the functions. I don't know what's up with my cats today. Anyhow, the code within functions, they're just normal code, right? They're like, there's nothing special about them. Okay. Whatever you can do outside of functions, you can do inside of functions, more or less. Okay. So functions can manipulate variables and call other functions, just like normal code outside of functions. Okay, so let's define our starting your car function in Solidity. Okay, so you'll see that I wrote this long ass thing on this line. Okay, function start car, only owner, public returns, bool success. What does this even mean in the slightest? I don't know. Okay, so obviously let's break it down again. Okay, so obviously the first phrase, function, it just tells the computer, the compiler, that you're declaring a function. Okay, you can even think of it as the type of this variable. Even let's not think about it that way. It's going to confuse people. So function just means that, okay, you're telling the computer, okay, I'm going to declare a function here. Okay, start car is the name of the function. You can name it whatever you want. The computer doesn't care. Okay. You just have to make it intuitive for yourself so that in the future, when you come back to your code, you know what the hell you were doing. Okay. And inside the parentheses, all right, this is normally where parameters that the function takes in would go to. Okay. Currently, we have none. I'll come back to this and explain what this is. Okay. But just know that every function, even if you don't have parameters, you need to have those pair of parentheses. Okay. Only owner. What is only owner? Only owner is a modifier that we applied. Okay. And think of modifiers as mini functions. They're small code snippets that you that usually check for certain conditions before another function is run. It's kind of like it's like giving your phone a pin on the lock screen or something. Okay, So it's something that you have to get past and be validated before the actual other main function is run, right? Modifiers are just attachments to other functions, okay? And the code and Solidity does not have modifiers built in. We have to declare modifiers, okay? So only owner, if we're using it here, then we have to have declared it elsewhere beforehand, okay? Public is the and only owner in this case means that only the owner can call this function. So that checks for the identification of the call of the sender or the caller, okay, if it's indeed the owner. All right. And public defines the visibility of the function, basically who can call it. Okay. So in other languages too, this works in a similar way. So in Solidity, we've got public, we've got internal, and we've got private. Okay. And we also have external. Okay. And we can talk about it in a bit. I think I have it somewhere else. Okay. Right now, don't worry too much about it. Okay. Returns bool success. Actually, you know what? Let's go back. Let's talk about it right now. Okay. So 1, 2, 3, 4. Yeah, 4 different visibilities. What do they mean? Okay. So first, let's talk about public. Public is the least strict visibility or accessibility option. Okay. So if a function is if it's designated as public, then it means that anyone is able to call it. Okay, people from outside of the smart contract, other functions within the smart contract, or even we're going to talk about inheritance in the future, or the function's children, and we don't have to talk about this right now. They all can call this function. Okay. So public is the most available visibility. And then we have external, okay? So external means that only entities outside of the current smart contract can call it, okay? So code within the same smart contract cannot call start car if start car is external. What is wrong? I don't know what's wrong with my cast there. Anyhow, so that's external. Okay, only external, only entities that are outside of the smart contract can call it. Okay, so so basically they can't be called from within. Okay, and then we have internal. Internal is kind of like the flip side of external. Okay, so basically all entities that are within the smart contract, so other functions within the same smart contract can call that function. The contract's children can call that function, but to people outside, that function is invisible. They cannot call it. Okay. And then we have private, which is the most secretive visibility. Private just means that only whoops. It means that only entities from within this smart contract can call it, excluding the children. Okay, so even if this smart contract has children, the children cannot call this function. Only code strictly within the smart contract, like within the same source file, more or less, can call it. Okay. We don't have, if you're confused, that's totally fine. I just wanted to kind of give you an idea of what they are, but we're going to get into it more in the future. Okay. Okay. So this entire line, okay, is also known as the function signature. Now that is actually a lie. I have to change that. Function signature, I believe, is only up to here. I think so. I think so. Only this part, including the parameters, is the function signature. Okay, actually just this part, because every single function has function. It doesn't matter. So just, I believe there's the function name plus the parameters it takes in is the function signature. Okay. You just kind of have to know that terminology. You just have to be familiar with it. Like there's no direct way to use it or anything. Okay, but you still have to know. Like when people talk about, okay, the function signature has changed, you have to know, okay, you have to know what it means. Okay, it basically means they change the name or the parameter it takes in. Okay, interestingly, I don't think the return type is a part of the signature. Okay. All right, modifiers. Okay. Modifiers, a modifier is a function that is mostly used to check for conditions. Okay, so let's say, I should start to rename these. Oh, also, I'm so sorry, I forgot to upload the slides. Oh my gosh. So the functions, so the modifiers, okay. So remember the only owner thing we talked about here, okay. So over here, this is how we write modifiers. Okay, so again, as I said earlier, a modifier is just a mini function that mainly does some conditional checks before another actual function is executed. Okay, so this is a modifier. Now, obviously, the formatting here is atrocious. You would, let's see, how would I format this? Okay, let me open up. A sec. Okay. Okay. This is this is what a modifier looks like in code. Okay. So it's all nicely formatted. Just know that this is how it's supposed to be formatted. But because I had to have it on the keynote, I had to condense it into one line. Otherwise, it's taking up too much space. Okay. So let's take a look here, and actually let me share everything so we can look at everything at the same time. Okay. So only owner. Okay, so that would be the name of the modifier. Okay, just like a function name, just like a variable name. Okay. And of course, modifier just means you're declaring a modifier, right? And in here, there's something called require. Okay, you can see on line 2 here. Okay, require. What does require mean? It basically means that you see how require takes in 2 different values. Okay, because there's a comma in the middle, meaning that it's, so this is whatever's before the comma is the first value it takes in, and whatever's after the comma is the second value it takes in. If we have 2 commas, then it would, and 3 values, then it would mean that the function or whatever it takes in 3 values. But right here we're taking in 2 values. Okay, require is something that's built in. All right, it's something that we didn't write. Okay, so what require does is that in the first value or parameter that it takes in, okay, that this parameter always evaluates to a Boolean. Okay, and basically what require is saying that I'm only going to let this code continue executing if the first parameter turns out to be true. Otherwise, I will revert the entire transaction using the error message provided in the second parameter. Okay, so so you see, a require reverts the transaction if a defined condition is not met. Okay, and then we have message.sender equals owner. What does that mean? Okay, so let's break that down a bit. Message.sender. Okay, first, what is message? MSG. Okay, it's not the thing that people put into their food when they cook. Okay, that's message. So message is an object that's given by Solidity. A message basically represents an incoming transaction. Okay. And within it, we have message.value, which is how much money is how much ether is attached to that transaction. Message.data, that's like the raw data of the transaction. And also message.sender, which is like, where is it coming from? Okay. So now what we're checking here is if message.sender is the same as some other owner variable that we stored elsewhere. Okay, this owner variable, we need to have it declared beforehand elsewhere within the smart contract, because we're comparing basically if the incoming caller really is the owner. Okay, and equals here means an equality comparison. Okay, so in computer science, one equal sign means assignment. It basically means assigning the values, whatever's on the right-hand side of the equal sign to the whatever's on the left-hand side. And if you guys recall how we're doing variables here, right? We're using one equal sign. So we're assigning the value 70 to the grade variable. But here we have two, okay? We've got two equal signs, meaning that we're checking if what's on the left is equal to what's on the right, okay? Now, if you want to check if they're not equal, you just change it into an exclamation mark, okay? So this means equality comparison. This is inequality comparison, okay? And this equality comparison will return true, will evaluate to true if they're equal, okay? And if they're not equal, it will return false, okay? And now you can see things start to make sense here. Well, like if the person who's sending this transaction isn't the owner that we defined elsewhere, then we revert the whole transaction and then give this error message back, okay? And in that case, okay, if the transaction reverts, then the code execution stops here, everything gets rolled back. But let's say message.sender is indeed the owner here. Then we move on to the next line, which is this. Now, what does this mean? Okay, this is something that's exclusive to modifiers. This just means that as a modifier, my job is done. Now move on to the actual function. That's what it means, okay? It means you've reached the end of this modifier without reverts. Okay, so we kind of went through a couple slides there. So any questions I can answer? And actually, you know what? Give me a minute. I'll have to get more water because my throat's dying. All right, do you have any questions regarding modifiers and functions? We should, because it's a pretty novel concept if you've never programmed before. Even if you have, and the modifiers is pretty different. All right. No questions so far?
I've got a quick one. So on the starting your car slide, we have the only owner modifier, but we also have it public. Does that just mean that only you can do it if you are the owner, but anybody can call that function?
Yeah,
I wanna make sure I
anyone
have
can call it. But if you're not the owner, then it'll be reverted.
Awesome, thank you.
Because
would be-
remember, owner is a variable. Okay, and we can have a mechanism built in to change who the owner is. Because everything it's all code. Okay, we can change anything we want, as long as we have it built in before we deploy the contract. Okay. So basically, so public is more or less about visibility. So basically, who can see it to begin with. If you have it as internal or private, then no human will ever be able to call it because they can't see it to begin with. They're not allowed to call it. So first you have to allow people to call it, and then you have to worry about, okay, only letting the right people in. Okay. Winston says, what if two public functions have the same name or signature? Same name is fine, as long, so again, name doesn't matter in terms of when it comes to functions. Signature is what matters. Okay, so you can have two functions of the same name, but if they take in different parameters, then they're still considered different functions. If they have the same signature, well, that's not allowed. That's just a duplicate function. You can't have anything duplicate in programming. Like you have to change a name or you have to do something, but you can't have two of the same thing. Okay. Okay. All right. Any other questions so far? All right, let's move on to the next slide then. Okay, now if we wrote some pseudo code for our car function, that it will kind of look like that. Okay, and of course these functions have to be separately defined, but that's what it will look like. So a function can call other functions. That's totally fine. Okay. Okay. Now we have more keywords. So this is more, this more has to do with when we actually start writing code. Okay. So actually I'll get to okay, I'll get to some of it when we actually start to write code. Otherwise it wouldn't make sense. So let's get pragma first. Let's look at view and pure. Okay. So a view function, what a view function means is that it doesn't write to the blockchain. Okay. View, it means like you're just looking at it. Okay. It means it's a read-only function that only it only allows you to look at it. It just returns to you some information regarding the current state of certain things. Okay. But it doesn't actually let you modify any state. Okay. So that's a view function. A pure function means that it is independent of the blockchain. Now, what does this mean? So for example, you have a function that takes in a number and returns the hash of the number. Okay. Now that is a pure function because hashing is independent of the blockchain. Okay, so a good way to think of to tell if a function is pure or not is to ask yourself, if I just remove this function from this smart contract and place it into a random other smart contract, would it still work? If it still works, then it means that function is pure. It means it's got nothing to do with the surrounding context, and that it can function independently. Okay. So that's pure. And also there was a homework question asking something about returning the results without calling get mem or something. Okay. So this is something, this has to do with the difference between the difference of return value, the differences in return values between regular functions and view and pure functions. Okay. So remember when we did the thing in Remix in class, and we did the addition 1+1 or something. Okay. When we click on the button in Remix, it didn't really give us any results. We have to call like get mem to get results. Like all we got was a transaction receipt. Even though the function said return a number or something, I think. And this is because so this is a rule, okay? For functions that are not view or pure, doesn't matter what the return values are, you will always get a transaction receipt. Okay, you won't get the actual return value. Now, the actual return value of the function, if it has any, is embedded within the transaction receipt, but it will give you a whole ass transaction receipt because you're making a transaction, right? But with view and pure functions, because they're read-only, because it doesn't write to the blockchain, right? Because they don't write to the blockchain, and if they don't write to the blockchain, it means there's no need for them to generate any transactions. They're just looking. In those cases, for view and pure functions, they will return whatever the return value is to you directly, right? No transaction receipts. Okay.
Sorry, I had a question.
Yeah.
So for the homework where they ask like to get the answer of a plus b without calling the getMem function, do we change that function to a view or a pure function?
Yeah, there are many ways to do it, but that's basically the idea. Just explain how you're doing or why you're doing it.
Okay.
Are view functions still subject to block computation limit? Yes, they are. Or at least I believe they do. Let me actually look it up. That's a good question. Okay, gas consumption of a view function. Oh yeah, yep. So they are still bound. They're still bound by the gas limit. Okay. It's just that you don't have to pay anything because there's no transaction happening, but because it's still computation, it's still bound to the gas limit. Wow, it's getting worse, isn't it? It's getting worse, just like the market. Okay. Any other questions so far? Okay. Well, there's abstract override event interface. Let's not talk about these for now because they have something to do with inheritance, which I don't intend to do right now because they're a whole other can of worms. Okay. And for today, let me actually check. So again, if you have any questions, please let me know. Okay. And I'm just looking ahead to see what else we have. Yeah, we can keep going. Okay. Do we have any questions so far with functions and whatnot? If not, we can move on to the next presentation about structs and arrays, more data structures. Okay, no questions so far. That's fine. So let's move on. Okay, let's close this. Arrays and structs. Okay, and also, you know what? Let me just post the previous one. Sorry about that. Wait, no, I already posted it. Never mind. I'm confused. Oh, it's already the previous one's already posted. Okay, let me post this one. Okay. Okay, the new slide has been posted. Arrays and structs on Notion. Let's get started here, okay? I'm just gonna present like this because now I can at least see my cursors and whatnot. Okay, so arrays and structs, all right. So first, let's go through some reviews. Okay, mapping function visibility. Now, who can, in their own words, try to tell me what mapping is? You don't have to be 100% correct. It can be a group effort. You can hop in and then if you think someone else's answer is missing something, you can add to it. But I want you guys to try to describe what is a mapping to me, because the best way to make sure that you understood something is for you to teach others. Okay.
It's a data structure where you can map from one type to another,
Yeah.
and you can kind of nest it too, as deep as you can as far as gas fees go.
What are some properties of mapping?
The elements have to be of the same data type. The keys have to be of the same data type. And so the same principle goes for the values, which is as opposed to Python, which allows data to be mixed in arrays. And then like the keys will continue to exist even if they are empty.
Yes. Yeah, very good, very good. That's a good overview of how mapping works. Okay, so mapping represents a one-to-one relationship between elements, okay, between keys and values. And for all the keys have to be the same type, all the values have to be the same type, but keys and values can be of different types. Okay. And and specific to Solidity, technically all the keys already exist when you first declare the mapping. Okay, they just all point to empty values. Okay, and you can also nest mappings within mappings within mappings. Okay, so that's good. Nested mapping. All right. So here I did a better example, I guess. Okay, so let's say this is still the same mapping as the one you saw earlier, but now I've added 4, 5, 6, 8. But you see, I say it's never been written to. Okay, here I'm just visualizing a random key that is empty. Okay, so in an empty key, in this case, a mapping that maps from a number to another mapping. Okay, for any random key that we haven't written into, the mapping that it points to will be completely empty. So it doesn't matter what value. So all the values, all the keys within that mapping will also point to empty values. Okay. What is this? I don't even know what this is. Okay. So let's follow this link here. Just download the slides from Notion. Let's follow that link. Let's open up Remix. Okay. And copy the code into Remix. Let me share my Remix screen. Okay. Let's call this mapping. So paste that in. Can you post link in Zoom chat? Oh yeah, that's right. You're all on Zoom. I'm sorry. Here we go. Okay, so we're sharing this screen. Everyone see my remix? Okay. Yes, no, maybe.
Yes.
Okay. So here is our mapping thing. Okay. Let's first take a look at what we have here. Okay, first, so you know what? I'll give you guys one moment to look over it. I have to get more water. My condition is getting worse quite quick. Okay. Okay, we're back. Right. Okay, so here we have just a very plain contract, and all it does is it plays with some mapping stuff. Okay. So first, so this is a contract whose name is review mapping. Okay, that's the name of the smart contract. So here I'm declaring a mapping. So this is how you declare a mapping. All right. The type, the visibility, and the name. Okay. Now in Solidity, in some older code snippets, you may see that they don't write the visibility. By default, if you don't write any, it just defaults to internal, but it's always good to be explicit. All right. Okay. So this is declaring the mapping here. Okay. Now the first one, this is get mapping V. So V stands for value and K stands for key, by the way. So this is, so get mapping V. You see this function, the name is get mapping V. It takes in a parameter of type number ITP-356 and whose name is K. Okay. So this type here in the parameter, okay, so let's kind of rewind a bit. So the reason we have, the reason we take in parameters in functions is because functions are self-contained code snippets. Like sure, it can do whatever it wants, but sometimes, and in the future, when we talk about scoping, you'll realize exactly what this means. But in order to get outside information into the function, we have to pass it in through parameters. Okay. So right here, what we're trying to do, get mapping V. So we have this mapping here. We're trying to get a value from the mapping. But in order to get a value from a mapping, we need a key, right? Because each key corresponds to a value, right? And key value, you use the key to look up a value. Okay. So we need a key, right? So this is why we basically, we have key in the parameter. We're trying to pass a key into the function so the function can work with it, or in this case, use it to get the actual value. Okay. Here we have external. Okay, that's visibility. The reason why I'm using external is because I know for a fact that no other function within this smart contract will call get mapping V. So I just made it external. So because external functions are slightly cheaper than public functions. Okay. And view means that we're only reading to the blockchain, reading from the blockchain, which makes sense. Because we're just trying to get some value. We're not trying to write anything, right? We're just trying to read. And returns a string memory. Okay, let's not worry about what memory means yet. Okay, so it's just returning a string here. Okay. And why is it returning a string? Because the mapping we declared earlier maps from a number to a string. Okay, so we're trying to get the value in the mapping, which is a string, and that's why we're returning a string. And the key is a number, which is why the parameter takes in a number. Okay, and all we do here, okay, is to return mapping at key K. Okay. So this is what we talked about with the square brackets, right? We use the square brackets in order to find values. We use square brackets and keys in order to find values and mappings. Okay, and return just means we're returning this value. Okay. So any questions so far, lines 6 to 11, that I can explain better?
Why is there an underscore before the mapping?
Okay, so this is just my personal naming convention that carried over from other languages. It's just semantics. So it's styling. Okay, so it's basically you don't have to do it. It's like uppercasing the letters after a period. You know, like you don't have to do it when you're writing, but it's good practice to do it. So usually, if a variable name starts with an underscore, it means the visibility is internal or private. That's just like when we're working with a variable, we can see that. We can immediately say, oh, okay, it's an internal or private variable. Like we don't have to look up the declaration to see what it is because there's an underscore in the beginning. So that's how we kind of know. It's like a convention that we follow that helps us code better or faster or something. But you don't have to do it, but it's good practice anyways. Does that answer your question?
Yeah, yeah, got it. Thanks. That's cool.
Okay, any other questions? This is the first time we're going through code together slowly, line by line. And if you have any questions, that's totally fine. We can spend as much time here as necessary. Okay. Just don't let it snowball because you'll get fucked. Am I allowed to say that? But you will, trust me. So if you have any questions, make sure you ask right away. Okay. Okay, so no more questions here. Let's move on to the next function. So this one, we're trying to get a value from the mapping using a key, okay? And here we're trying to set a value in the function, right? And just like getting the value, we need a key, right? To set a value, we also need a key, because remember, it's key value, key value. If you only give it a value, it doesn't know where to place that value. It's like, think of keys as like what is it? Your parking spot number. Okay. Like if I give you a permit and I just go and tell you, you can park your car in this, actually, hang on. So let's say it's a valet situation. Okay. It's a valet situation. And, the key is like the parking spot number. The value is like your car, access to your car. Let's say I'm a valet boy. Okay. I'm giving you your car back. I don't just hand you the keys and say like, here you go or something. I mean, of course I have to drive the car up, bring the car up for you, but let's say you want to go back to the car to get something. I don't just give you the keys and that's it. I have to tell you where it's parked at, right? Which spot, what spot number, like what parking spot number it's at. So it's the same idea with keys and values when you're just trying to set a value. Without a key, the mapping, like there's so many spots in the mapping, it doesn't know where you want to place it at, okay? So when you're getting a value, you only need a key because the values already exists. But when you're setting a value, you need both the key and the value. Okay, that's because the key, you use the key to tell the mapping where you want to store the information, and you use the value to tell the mapping what you want to store at that location. Okay, and it's public because I do call it a bunch of times within the same smart contract. I can see in a different function. Okay, if I change this to external, you'll see that they'll give an error saying that it says undeclared identifier, meaning that it can't even see that this exists because it's external. It's not visible to anything that's within the smart contract. So I have to change it back to public and the errors are gone. Okay. And in here, and again, don't worry about memory for now. Okay. And in here, it's just, you know, same old, right? We're just, we're setting a value into a mapping at this key location. Okay. Just like what we talked about in the slides. All right. Any questions so far?
Why do we need to use the setter instead of just calling like mapping like 0 jack?
Right. Well, how do I call it here as a user?
Oh, yeah, you can't. Okay.
Right. Yeah. Within the code, you don't have to. I mean, it could be external, you're right, but I'm just because I just wrote this test mapping function so I can quickly like run through all these so I don't have to do it manually every time. So this is, so like, if not for this testing code, this will be external, if that's what you're asking.
Yeah, but is there a way to like set the like 0 as the key and jack as the like value by just using like brackets?
Yeah, I mean, it's basically that.
Okay, yeah, that was my question. So
Yeah.
you don't need to use this setter.
I mean, if you look at this, you're really just plugging in the values
Yeah.
to this. Yeah. Yeah, I'm just using this because I want to test things out or something. Yeah. Yeah, I'm just recreating the state real quick. Okay. All right, any questions so far? By the end of next week, I'll take a look at how many people are enrolled again and see how many people I scared off. Okay.
So,
Should be-
so does this mean you like the different numbers to the different owner's name? Basically, that's what you are doing, or
not owner's name, but just different numbers associated with different, so different keys, different
a
values.
different? Okay.
Yeah. So this just calls this function, which in turn does that. So that's really just setting values inside of mappings. I'm just doing this to show that you can call functions from other functions. Okay. Yikes, it's really bad. Okay, any other questions? Okay, no questions so far. Okay, let's run through this real quick. And then that'll be it for today because I'm about to die. Okay, so let's deploy this contract here, okay? Deploy it and then you can see it here. Now, before we do any setting or we click on anything right now, let's just try to get some key, some value from the mapping. Let's say we want to get 0. You can see 0 right now, it gives us an empty string. Why? Because right now we haven't done anything to anything yet, so everything's empty. Okay, when everything's empty, the default value is for string, it's an empty string. Okay, and same thing for 1, same thing for 2, 300, and don't worry about this 0 here. Okay, 400, you know, everything is empty. Okay, once we set the mapping, okay, let's actually instead of calling this function, let's call this test mapping function, because it will just set all of these at once. Okay, let's click on it, test mapping. Okay, it's done that. Now if we look at 0 again, see your return is Jack. Okay, if I do 1, returns James. Okay, do 5534, returns some other string, just like how we have set everything here. Okay, and of course for the ones we haven't set, let's do 5000, then it's still empty. Okay, and now in a mapping, you can also overwrite what's already there. Okay, so right now, key 0 is Jack, right? So what if I want to set it to something else? Okay, I want to set this to, let's say Emily. Okay, key 0 Emily. So right now it's still Jack. I haven't clicked on transact yet. Okay, let me click on transact. If I click on this again, it turned into Emily, right? So you can just overwrite values just like that. Okay, just by doing this, okay, you can overwrite whatever value that already exists. Okay. All right, any questions so far?
So if you didn't have the overriding, like the mapping with the K, and you said equal to V, and you just had the test mapping, the external underneath it, then could you not customize it like you did before?
What do you mean?
Like if you put in a value like into V, and you didn't have like function like set mapping V, like the one with like that one, yeah. And you just put something in, but like assuming you didn't have that function, then that wouldn't work, right? Like it wouldn't output the value that you entered.
Sorry, can you repeat the question again?
Yeah. So like you know how before when you plugged in like Emily and you didn't change any of the arrays below in like test mapping external, but you just changed something within like this, I think, set mapping. If you didn't have the function from lines 13 to 15, that wouldn't have worked, right? Like you need.
No, well, if I didn't have this function here, okay.
Yeah.
And well, these won't work, first of all.
Okay.
But really what it's doing is just like doing this internally. But if I don't have this, then I wouldn't have, then this wouldn't be here. So I basically I can't modify the mapping at all. Unless it's something
Okay.
I've already written in code beforehand.
Okay.
Yeah.
Makes sense.
So you have to realize, okay, so whatever we do on the right side here, it won't be reflected on the left side until I redeploy, and that will be a new instance. It will
Right.
not modify what's already here. Okay.
Okay. Thanks.
And also, can you link external databases to Solidity? Sadly not, okay, at least not directly. You can look into something called Chainlink external adapters. Yes, or is it, yeah, it's the Oracle problem, exactly. So you can look into that, but directly in a straightforward way, no. Basically, Solidity, the entire Web3 blockchain ecosystem is pretty walled off to everything else. It's very segregated. It's very siloed. Okay. All right. Any other questions so far?
Is that syntax at the beginning always how you
Can you tell me the line number?
the line number 7? So you always initialize or create a mapping using that syntax where the name of the mapping is at the end.
Yeah, so for example, if this is the same across all the variables. So if I want a number, or public. Yeah. So and you notice here, okay, notice I never initialized this number. So if I didn't initialize it, then it will just be the default value, which is 0. I can also bool public. So you see the pattern, it's type, okay, type, visibility, name, type, visibility, name, type, visibility, and a name. So that's like the pattern here for declaring variables.
Got it. Thank you.
Can you make REST calls? Same thing, look into Chainlink external adapters. So basically you have to leverage their Oracle network. You can't do it directly on your own. Like it's not aware of anything that's outside of the blockchain. So you cannot make REST calls. No, you cannot. Not natively anyways. You can use it, you can do it with Chainlink. Yeah. So it's quite limited. Okay. All right, any other questions so far? I'm not going to go further because I'm about to die, but also because we're out of time. So I'm just going to stay here for any questions. Okay. Otherwise, I don't know, Thursday, if I get better, I'll show up in person. If not, I'll send out an email in the morning. Okay. But if you don't have any questions, thanks
Is
for
homework
coming.
2 due on Thursday?
No. I don't have a due date for that yet.
Hmm.
So
probably
at
next
the
week?
earliest will be next week. Yeah.
Okay.
Yeah. All right. I'll stay here for any more questions, but other than that, you are free to go.
Jack, I'm still a little confused on the set mapping
Yeah.
because, well, like, where do you put that anywhere before that? Or is it just like something that Solidity knows? Or
What do
does
you
that
mean?
not matter?
Put what before what? Tell me the line
Okay,
number.
sorry. Like, do you identify set mapping before you like write that function?
What do you mean identify set mapping? Because I'm defining it here.
Okay, you're defining it right there.
This is what I'm defining what set mapping V is. Before this doesn't exist. I'm defining what it is and how it works.
Okay, I see.
And here I'm using what I just defined.
So you defined it in line 14.
Yeah, line 13 and 15.
Yeah, okay.
Mm.
But then. Oh, I see, okay. Okay, yeah, that makes sense. Thank you.
Yeah. Mhm.
I have a question.
Yeah.
This it might be kind of silly, but
No, that's fine.
so on Remix, like when I'm like or just when we're uploading the
Yeah, let me stop recording.
okay.